Greetings everyone. I am Smriti K, currently pursuing fourth year of Electronics and Communication Engineering at Savita Engineering College. Today, my topic is Smart Village WLAN Design. So, what is a wireless local area network? A wireless local area network is a wireless communication technique that connects two or more devices using high frequency radio waves based on IEEE 802.11 standards within a localized area. Instead of relying on physical copper or fiber optic cables to reach end devices, access points convert over-the-air RF signals into standard wired Ethernet frames to connect devices to local servers or internet gateways. The various types of wireless networks are wireless personal area network, wireless local area network, wireless metropolitan area network, and wireless wide area network. Why we designed a WLAN for a smart village is rural and semi-urban communities often suffer from a severe digital divide. Physical cable installation across rural landscapes is cost prohibitive, leading to isolated administrative units, lack of digital healthcare infrastructure, and limited access to e-learning resources. The key challenges in rural wireless deployments is unmanaged interference, wherein overlapping access point channels create severe co-channel interference and signal degradation, bandwidth hogs, security vulnerabilities, lack of local content. What I solved in Cisco Packet Tracer is off-grid local resilience, configured a local multi-service server 192.168.1.10, hosting an offline accessible smart village WLAN portal over HTTP, ensuring local services remain functional regardless of external cloud service access. Structured quality of service bandwidth division. Define priority allocation for healthcare and e-learning traffic while rate limiting public access. Planned non-overlapping 2.4 GHz channels 1611 with a fixed 140 meters coverage radius, which is interference mitigation. End-to-end encryption using enforced WPA2 PSK AES encryption across all access points with central VLAN isolation. The components used are ISR 4331 Rota 0. This functions as a primary layer 3 default gateway 192.168.1.1 bar 24. It routes traffic out of the village subnet and handles inter-subnet communication. 2960 switch 2 acts as a central layer 2 aggregation switch interconnecting all infrastructure components over 100 Mbps fast Ethernet backhaul links. 192.168.1.10 server 1 is configured as a multi-server local host executing DHCP addressing services and hosting the Smart Village WLAN portal over port 80 HTTP. WLC Wireless LAN Controller 192.168.1.15 provides centralized management for radio frequencies, authentication policies, and roaming parameters across all lightweight access points. Access point 0, 1, and 2 physical wireless transceivers broadcasting the SSIDs into designated geographic sectors, that is admin, health center, and e-learning hub. The smartphone 0 as well as the tablet PC 0 wireless mobile endpoints associated with the network via WPA2 PSK. First, we click on the router 0 and move to the CLI tab where we have executed the enable prompt, after which we have executed show IP interface brief. This shows us that gigabit Ethernet 0 bar 0 bar 0 has the IP address of 192.168.1.1 with the status of up as well as the protocol is also up. Moving on to switch to and the CLI tab where we have executed enable prompt. After that, show interface status, which has shown us that fast Ethernet ports FA01 0 bar 1 to FA0 bar 7 is, are active, that is connected in WLAN 1 operating at full duplex and 100 Mbps. Clicking on access point 0, moving on to config and under port 1, we see that the port status is on and the SSID is configured as village underscore smart underscore Wi-Fi with a 2.4 gigahertz channel as 6 and the coverage range in meters as 140. The authentication is WPA2 PSK with the PSK passphrase as village at 2026. The 2.4 GHz 6 access point 1 uses channel 1, access point 2 uses channel 11 to achieve complete frequency isolation. The coverage radius fixed at 140 meters to contain cell boundaries and reduce intercell interference. Now moving on to smartphone 0 under the desktop, go to IP configuration. As we can see, the IPv4 address is 192.168.1.101 and the subnet mask is 255.255.255.0 and the default gateway is 192.168.1.1 with the DNS server 0.0.0.0 which is a local resolution handled via server 1. Now moving on to the smartphone 0 desktop under the command prompt, they have executed ping 192.168.1.1, which is pinging the default gateway, and we received 4 ICMP replies with 0% packet loss. This proves that the wireless over the air frames are successfully bridged through access point 0 to switch 2 and routed by router 0. We have 0% loss. Moving on to the pinging of local server using the command 192.168.1.10, we see that the returns are 4 ICMP replies, 0% packet loss, proves that full connectivity between mobile clients and internal village server resources. Now click smartphone 0 and move to desktop and go to web browser and enter in the URL prompt as 192.168.1.10 and give the action go, whereas we can see the customized Smart Village WLAN portal page renders on screen with the header Smart Village WLAN portal and the welcome message is welcome to the village community and e-learning network. The status is connected via high-speed WLAN and services offered are admin portal, health center records, e-learning hubs. The footer is powered by Cisco wireless infrastructure. Moving on to the simulation. Thank you.